Stop measuring diagonals by hand. Automatic skew calibration using a toolhead mounted camera. Hi everyone, I'm Marius. In this video I want to show you the software I developed which lets you automatically calibrate the XY skew of your printer using a camera. If you run Klipper, you will like this, but the same idea is also applicable for CNC routers and cutters. Last time I used this few euro USB endoscope camera to calibrate pressure at once, and today I'm using the exact same camera for the skew calibration. But this time you don't even need to install anything on your printer. You can just run it remotely from your laptop. In addition, it's also much more robust. Quick note before we dive deeper into the project. It has been a long time since I released my last video, but I have been busy with life and other projects. But finally found a bit of time to implement the feature I was already thinking about when I first mounted the camera to the toolhead. In the meantime, Bambu Labs released the H2D printer, which comes with a similar feature. But now we can do a similar thing using only open source tools. Most of the heavy work is done by OpenCV, and the remaining parts of my program are mostly wipe coded together. What is skew? In an ideal world, a printed square has perfect right angles. In reality, it can come out as a slight parallelogram. Maybe the frame of the printer is a bit off, or on a Core XY, the belt alignment and lengths aren't matched. Klipper lets us correct that in software using the setSkew command and 3 measured lengths. I have here an artificially extreme skew of about 10 degrees to show what I mean. Normally, you print a special calibration pattern like one of these, then measure with calipers to see how it came out in the real world. How it works. Use a calibrated camera, more on this later. Place the ChArUco board on the bed, roughly centered. Orientation doesn't matter, rotation is fine. The only important thing is that it doesn't move while the printer moves the camera. On a bed slinger that can be tricky, so I reduce the default move speeds a lot. The camera then moves the printer to different positions, grabs images and estimates the board's pose. It then computes a transformation that maps board coordinates to printer coordinates. From that, it computes the 3 lengths required and prints your skew in degrees, plus the Klipper setSkew command to fix the skew in software. Why this is cool? No manual measurement required. You don't need calipers. It's also more accurate, and one more use of a nozzle camera. And it can also be used for other CNC machines like laser cutters or mills, etc. What's a ChArUco board? You may know chessboards for camera calibrations, but ChArUco boards are even better. They are a hybrid of a chessboard and ChArUco markers. You still get the sub-pixel chessboard corner detection, and the white squares contain ChArUco markers and code an ID. That means the camera doesn't need to see the whole board. Partial views still work, because the IDs and the known fixed layout lets OpenCV figure out which corners it's looking at and solve the pose reliable. What do you need? Hardware-wise, get a cheap USB endoscope camera, which can do Full HD and has a flexible cable. If you got a rooted Creality K2 Plus or Pro, you can likely use the built-in nozzle camera for this, but unfortunately I don't own one to test. How to create the board? I uploaded the board in both A4 and letter size. Download the one for your paper size and print at 100% scale. The black square should measure exactly 5 mm. I'm currently in Colombia, where I had a thin fiber board laser cut for about the price of an espresso doppio. I then glued the paper on top of it. You can probably just glue the paper to your bed with a glue stick or put it in a picture frame. The important part is it's flat and reasonably stiff. For the way I recommend calibrating the camera, the board needs to be lifted at the sides. Trim any paper overhang. Camera calibration. We can only be truly accurate if we know the camera intrinsics, so we can undistort the image. You only have to do this once per camera, and it involves taking several dozens of images of the board from different angles. It's important to capture not only straight-on views, but also tilted ones. I added a guided command that walks you through this. It takes pictures from different positions and heights, then asks you to prop one side of the board to create an angle and repeats. It stores these results for later use. I'm not using intrinsics yet in the pressure advance flow, but this will help there too. Thanks for watching. Please click like and subscribe if you enjoy my content. Have a nice day.